Unidimensional arrays are indexed and sliced just like lists. For multidimensional arrays, we can index each dimension using start-stop-step statements separated by commas. For a 2D array, the first field is for rows and the second for columns. Here we index the first row, here the second entry of the first row. Here we reverse the order of the rows or the columns. The new axis object can be used to expand the dimensionality of an array, as we do here to generate a row and a column matrix from a 1D array. Besides the start-stop-step notation, it is often convenient to index an array passing another container of indexes or Boolean values. The former approach is known as fancy indexing. Here we use it to get the diagonal elements of a square matrix passing two equal ranges. In the latter approach, we pass an array filled with true or false entries of equal shape as the original array. This is called a Boolean mask, and the resulting array contains only the items of the original array which line up with the true entries of the mask. Boolean masking is particularly useful to select entries which satisfy a given criterion. For example, we can select the diagonal elements of our 2D matrix by generating a mask with true entries where the values are divisible by 10. Now let's see how to load and save NumPy arrays. We use the shell command echo to create a small text file consisting of 2 comment lines followed by 2 columns of integers separated by blank spaces. We view it using the shell command head. To load it, we use the method load.txt, which takes as arguments the file name, the characters used to mark the comment lines, and the type of the numerical values. Alternatively, we can tell the parser to skip the first 2 lines. In both cases, we obtain a 5x2 array. Setting the option unpack to true, we can load the various columns into separate 1D arrays. As a final example, we generate a text file with 3 columns of integers separated by pipelines, which we load into 3 1D arrays, specifying that the delimiter is not the default blank space, but the pipeline. To save the array, we use save.txt. We specify a string for the name of the output file, the array, which we create by stacking the columns together using C underscore, the format of the numbers, and 3 dots as the delimiter. C underscore is only one of the many methods to stack NumPy arrays. In this case, we can achieve the exact same result using column stack or vstack followed by transpose. If we want to split the 5x3 matrix, we can use split. With axis equal to 1, we split along the columns. We indicate the number of arrays that we want to obtain with an integer as the second argument. We can also indicate the index of the column where we want the array to be split. The same can be done for row splitting by setting the index equal to 0.